In case you're wondering, no, it's not a clickbait title. This video is long and boring. So, are you ready for it? You might just learn something. At the very least, I can say you might learn from this video that it's okay to make mistakes if you don't already know that. And don't be afraid to admit when you do, because I made a couple of doozies on here. Not going to tell you what they are just now. But if you get far enough into the video, I will tell you about one of the mistakes just before I make it. I'm recording this just to edit in and put that in there. So that way, hopefully, nobody will mislearn because of my mistake. So I did want to warn that the mistake is coming up. And I won't say what it is just now. And at the very end of the video, I'll tell you about another mistake in case you missed it. So that video is right near, that mistake is right near the end. So if you get near the end, please watch the last little bit of it, just to make sure that you don't end up thinking that I didn't make a mistake where I did. Welcome. The binary number system is so easy. It's boring. Well, it's a matter of opinion. It can be boring because it's made out of a lot of ones and zeros. I mean, seriously, literally, 0 and 1. That's it. That's all there is. 0 and 1. Nothing more. There is no 2, 3, 4, 5, 6, 7, 8, 9 as far as the digits go. Now, that doesn't mean you can't build higher numbers. Of course, you don't just stop counting at 1 and go, well, that's it, I'm done. I ran out of numbers, can't count any higher. No, in binary, you count with zeros and ones. Just like in decimal, you count with zeros, 1s, 2s, 3s, 4s, 5s, 6s, 7s, 8s, and 9s. So let's see, if I make a little room on my screen here. And just clear all this out of the way. Now, here we have two numbers, 0 and 4. If I want to put something in between them, if I want a number that's in between these two numbers, the easiest way to do that, of course, is pick a number exactly halfway in between them. So it's halfway between 0 and 4. Now, I'm not using binary right now because notice there's a 4 there. I'm using decimal, ordinary number system. So what is between 0 and 4? Halfway between 0 and 4. Well, of course, half of 4 is. That would be 2. So what if I want to put something in between 0 and 2? Again, the easiest way is to go halfway between them, which is 1. Well, easy so far, but what if I want to put something between 2 and 4? Well, again, it's gonna be, the easiest one is gonna be halfway in between them. And in this case, that's the number 3. Now, so far, this is pretty easy, right? What happens when I want to put something between 0 and 1? Well, now, if you haven't learned fractions or decimals yet, you might have a problem there. But let's just say we decide to go with fractions. So we'll call that number 1/2, which is half of 1. Okay, that's easy enough. What if I want a number halfway between 1 and 2? Well, that's going to be 1.5. What if I want a number halfway between 2 and 3? Well, that's going to be 2.5. Notice a pattern here. What if I want a number halfway between 3 and 4? Well, again, that's going to be 3.5. So what if I want to put a number between 0 and 1/2? What would be halfway between those two? Well, this is where it starts to get a little bit complicated. If you're if you're an adult and you know math, at normal adult level, you probably already know the answer. If you're a kid watching this who hasn't gotten to fractions yet at all, this might be a little confusing at first, but don't worry about it. We have 1/2, which is a 1 over 2, meaning 1 part out of 2 as the number between 0 and 1. Well, 2 plus 2 is 4. So if I want half of 2, I want to divide by 2 again. In other words, 1/2 part of 1/2. So 1/4. And what if I want a number halfway between 1/2 and 1? That would be 3/4. Now, 1/2 is also equal to 2/4. So, in a sense, we're just counting here. We go 0, 1/4, 2/4, 3/4. 1 would be 4/4. In between 1 and 1.5 would be 5/4, or 1 and 1/4. 5/4 is 4/4, which is 1 plus 1/4. In between 1.5 and 2, well, 1.5 is 1 and 2/4. So we want 1 and 3/4. Halfway between 2 and 2.5, well, 2 is 8/4, or 1 and 4/4. So we're going to want 2 and 1/4, or in other words, 9/4. In between 10/4 and 12/4, or in other words, in between 2.5 and 3, we're going to have 2 and 3/4. That's 8 and 4/4, or 12/4. Wait, did I say that right? No, sorry. 8 and 3/4. 11/4. Yeah. I'm not perfect. None of us are. I made a mistake. But when you make a mistake, don't forget, it's okay to call yourself out on it. It's okay for someone else to call you out on it. It's all right to be wrong. But it's important to recognize when you're wrong and make the correction if you can. Because if you can't accept the fact that you're wrong, then you'll never recognize when you have something that you need to relearn or learn correctly or learn to do better, because you'll never know that you were wrong. You got to be able to recognize that. So moving on, what would be between 3 and 3.5? Well, of course, there are a bunch of numbers between there. But what's directly halfway between 3 and 3.5? Well, that's going to be 3 and 1/4. And halfway between 3.5 and 4, that would be 3 and 3/4. Now notice all of those fractions that I've just added have a 4 in the denominator. The ones I did in the last time across between 0 and 4 had a 2 in the denominator. And technically, the ones before that had a 1 in the denominator. That would be the 1 and the 3, which is 1 over 1 and 3 over 1. And the one before that, halfway between 2 and 4, technically kind of had a 1/2 in the denominator. Now that might not be real obvious, but if you write a fraction of 1 over 1/2, or in other words, 1 divided by 1/2, then that would be the reciprocal of 1/2. Anytime you divide 1 by something, you get the reciprocal of that thing. Well, the reciprocal of 1/2 is 2 over 1, which is 2. So, moving on. What do you expect to be in the denominator if I try to put a number between 0 and 1/4? Halfway between again. Well, so far we've got in the denominator we go 1, 2, 4. What's next? Well, you might think 2, 4, 6, 8, even numbers, right? But 1 isn't an even number. So that's not the pattern we're looking at here. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. The answer is 1/8. 8 is in the denominator. What's between 1/4 and 1/2? Halfway between 1/4 and 1/2 is 3/8. Halfway between 1/2 and 3/4, 5/8. Halfway between 3/4 and 1, 7/8. Halfway between 1 and 1 1/4, that's 1 and 1/8. Between 1 1/4 and 1 1/2, halfway between is 1 and 3/8. Halfway between 1 1/2 and 1 3/4, 1 and 5/8. Halfway between 1 3/4 and 2, that would be 1 and 7/8. Halfway between 2 and 2 1/4, that would be 2 and 1/8. See a pattern here? Halfway between 2 1/4 and 2 1/2 is 2 and 3/8. Now you might wonder why I'm showing you all these fractions in decimal when we're here to talk about binary. Well, binary is base 2. And notice we multiply by 2, multiply 1 by 2 to get the 2 that goes in the first denominator, and multiply that 2 by 2 to get the 4 that goes in the second set of denominators, and multiply that 4 by 2 to get the 8 that goes in this set of denominators. So again, in the next set of denominators, what are you going to expect is going to come next? In between 0 and 1/8. What's half of 1/8? It's 1/16. Halfway between 1/8 and 1/4, 3/16. Halfway between 1/4 and 3/8, 5/16. Now notice, this is really not that hard. 7/16, 9/16, 11/16, 13/16, 15/16, 1 and 1/16, or 1 and 1/16. Or another way of looking at it, 7/16. Between 1 and 1/8 and 1 1/4 would be did I say that wrong? 1 and 1/16 is the same as 17/16. Between 1 and 1/8 and 1 1/4 would be 19/16, or in other words, 1 and 3/16. We keep going. 1 and 5/16, 1 and 7/16, 1 and 9/16, 1 and 11/16, 1 and 13/16, 1 and 15/16, 2 and 1/16, 2 and 3/16, 2 and 5/16, 2 and 7/16, 2 and 9/16, 2 and 11/16, 2 and 13/16, 2 and 15/16, 3 and 1/16. So if I follow that pattern all the way to the end, here's the last one between 3 and 7/8 and 4. Halfway between those two is 3 and 15/16. And notice, add one more 16th to that, and we have 4. If we wanted to continue this pattern, the next fraction would have 32 in the denominator. But we're not going to do that because, well, decimal can be boring too. Fractions can be boring. Anything's boring if you do too much of it. So let's move on. Okay, we have again 0 and 4. And if I want to go in between the 0 and 4, halfway between is the number 2. If I want halfway between the 1 and the 2, it's the number 1. Halfway between the 2 and the 4 is the number 3. Now, we went over this last time, but now I'm going to do something different. Halfway between 0 and 1, instead of saying 1/2, we're going to call this 0.5. Now notice the 1 is in the ones place in the number 1. The 0 is in the ones place in the number 0. The 5 is not in the ones place. It's in the 1/10ths place. A fraction of 10, or a fraction, 5 parts out of 10. Well, 5 parts out of 10, 5 is half of 10. So that's 1/2. And over here, we're going to have 15 parts out of 10, halfway between 1, which is 10 parts out of 10, and 2, which is 20 parts out of 10. So 1.5. Halfway between 2 and 3, 2.5. Halfway between 3 and 4, 4.5. Now, this looked pretty easy again, doesn't it? But doesn't stay that way. What comes in between 0 and 0.5? Well, this time, we're not going to be just sticking a digit on the end. In between 0 and 0.5 is 0.25. It's kind of like saying the 5 represents 5 in the 10th place and 0 in the 100th place. 5 0 is 50. Half of 50 is 25. So we want 25 100ths, which is half of 50 100ths. In between 50 100ths and 100 100ths, halfway between is 75 100ths. So halfway between 0.5 and 1 is 0.75. Halfway between 1 and 1.5 is 1.25. Now you might notice this is getting a little bit more thought intensive here. If we really want to work this out, it's not a terribly difficult task, but at least it's not boring, right? Because there's something to figure out. So this is kind of what I mean about binary being so simple, it's boring. Because what is there to figure out? Well, we'll get to that. Let's go ahead and continue this pattern here. 1.75, 2.25, 2.75, 3.25, 3.75. Now notice these are all 2 digits after the decimal point. And when I get to between 0 and 0.25, will I have a 3rd digit after the decimal point now? Sure enough, we got 0.125. So between 0.25 and 0.5, 3 digits again. Sure enough, 3.75. What about between 0.5 and 0.75? Yep, 0.625. What about between 0.75 and 1? 0.875. What about between 1 and 1.25? That would be 1.125. Now notice we had the 0.125 up there, and the one we added after that, after the 0.25, was the 0.375. So in between 1.25 and 1.5, we get 1.375. So there's a pattern here again, like there was with the fractions. Each time in between these numbers, we're literally adding another 0.25 each time. Or is it 0.25? Did I say that wrong? I might have said that wrong. We're adding another, yeah. Is it 0.25? Oh, yeah. We're adding 0.25 to... Well, we're adding 0.125 to the number that we're coming after. Yeah, you know what? 0.25. That's right. I said that right the first time. I have no idea why it threw me off. 0.25. Okay, let's do this. Here. This one we just put in is 1.375. Okay, after 1.5 will be 1.5 plus 1.5 plus 0.125, which is 1.625. Add the 0.1 to the 0.5 and you get 6, and then the 25 from the 0.125 is being added to 0. So that'll be 0.625. But if we look back at the 1.375 and we do it that way, then we're adding 0.25 to that to get to this position. Well, 0.25, added to 1.375. The 1 stays where it is. The 0.2 gets added to the 0.3. That gives us 0.5. 3 plus 2 is 5. The 7 gets the 5 from 0.25 added to it. Well, 5 and 7 is 12. So we're going to be carrying 1 then. So the 1 carries over to the 5 in the 1/10ths place, and we end up with 6 there. So we'll end up with 0.625. Same answer, different way of coming about it. Between 1.75 and 2 is 0.1875. And so on, 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 until we've run out of this row of inserts, and now we're back to the beginning. So what should I expect to get between 0 and 0.125? Some people might already know the answer, but just think about this. We had no digits after the decimal, and then 1 digit after the decimal, and then 2 digits after the decimal, and then 3 digits after the decimal. Should we be getting 4 digits after the decimal here? There it is, 0.0625. Now, can you be sure this pattern is going to hold? Here we got 0.1875, and here we get 0.3125. Now that's getting just a little bit on the complicated side, isn't it? So we're adding 1/8, 1/16 each time now. We're back to adding our 1/16 like we did with the fractions. And I'm just going to go ahead and fill this row out. And hold on, it scrolled off the screen. Let me bring that back on. And you can see each one. Again, we're just taking the number out of the two numbers that we're trying to get one halfway in between, since those are 1/8 apart, and we're just adding 1/16 to the first one. Or we can subtract 1/16 from the second one, either way, and that gives us our number that's halfway in between them. But notice, it's hard enough to do that in fractions. And the smaller the fraction, the more times you want to go halfway in between, the harder it's going to be. And what if you have some arbitrary set of numbers like 37 and 156.125, and you want to go halfway in between those? Well, then you're getting a little more complex, and you might want to pull out a calculator and just add the two numbers together and divide by 2, which will work. But let's just go ahead and fill this out, and then we're going to get onto the binary here. Here's 3.8125, and the last one we're inserting between 3.875 and 4 is going to be 3.9375. So, scrolling this up out of the way, and let's put this on the screen. Now, why that? Why 0 and 100 this time instead of 0 and 4 like we did the other 2 times? Well, the answer is this isn't 0 and 100, because now we're in base 2, binary. 100 represents a 1 in the 4's place, a 0 in the 2's place, and a 0 in the 1's place. So this is a binary representation of 4. In binary, you would count 1, 1 0, 1 1, 1 0 0. 1 0 0 is your 4th number. So what is going to go halfway in between 0 and 1 0 0? Well, again, you count 1, 1 0, 1 1, 1 0 0. So 1, 1 0, 1 1, 1 0 0. Inserting here from 0, 1, 1 0, 1 1, 1 0 0. But that's your whole numbers. What happens when you want to go halfway in between 0 and 1? Well, I did say binary was easy. 0.1. 0.1 on after your 0. How about between 1 and 1 0? Again, take your 1, put a 0.1 on the end. What about between 1 0 and 1 1? Well, you take your 1 0 and you put 0.1 on the end. What about between 1 1 and 1 0 0? Take your 1 1, put a 0.1 on the end. So all we're really doing is we're adding in a 1 in the 1/2 place on each one of these. And adding that 1 in the 1/2 place is really easy to do because the 1/2 place had 0 in it. So you're adding something to 0. And adding to 0, of course, is real easy because whenever you add something to 0, you'll get the something that you added to 0. So what about here? Between 0 and 0.1. Well, again, 0.1 in binary is 1/2. So half of 1/2 is 1/4. So we want a 1 in the 1/4 place. Or in other words, in the place value of 2 to the negative second power. Well, 2 to the second power is 4, so 2 to the negative second power is 1/4. So that's going to be our second digit, 2 to the negative second power, therefore our second digit after the decimal point. 1/2 was the first digit after the decimal point, that's 2 to the negative first power. 1/4 is going to be the second digit after the decimal point, so 0.01. Again, we're just taking our 0, or 0.0000000, however many zeros you want to throw on the end because they won't change it. And we're adding 0.01 to that. We're adding a 1 in that second digit after the decimal point. So what's going to go between 0.1 and 1? Well, again, take your 0.1 and add a 1 in the second decimal place after it. What's between 1 and 1.11? Well, halfway between, what's halfway between 1 and 1.1? Well, halfway between 1.1 is 1.01. Halfway between 1.1 and 10 is 1.11. Halfway between 10 and 10.1 is 10.01. Halfway between 10.1 and 11 is 1.11. This is really not hard math. Halfway between 11 and 11.1 is 11.01. Well, I hate to interrupt myself to point out that I'm about to make a really big mistake, but I'm leaving it in. So, I need to tell you what it is. I'm about to misuse the phrase, the term decimal point, when what I really mean is binary point. So let me explain that. When making decimal fraction numbers using a decimal point, we might write, for example, 1.5 to mean 1 and 5/10, or 1.05 to mean 1 and 5/100. That's using the decimal system, so the point is a decimal point. Now, you can use the same point in binary, and yes, it often gets called a decimal point, but that's technically incorrect because decimal is base 10. It's a binary point, and I make that mistake coming right up here multiple times before I catch myself at it. So When I catch myself at it, I will point it out. But I wanted to point it out in advance in case anybody doesn't quite watch far enough to catch me catching myself. So at least you don't end up walking away slightly misinformed. The binary point, uh, when you put, for example, 1.1, that means 1 and 1/2. 1.01 is 1 and 1/4, or in other words, 1 and 1/2 of 1/2. 1.001 is 1 and 1/2 of 1/2 of 1/2, or in other words, 1 and 1/8. So it's really not correct to call it a decimal point. Again, it's common. Be ready for that out there. Yeah. Back to the instructions. Thanks for hearing me out. Now, notice all I'm doing is I'm taking my 1, I'm putting a 0.0 after it so that the next digit I'm adding on is in the correct place value, the 1/4 place, or the second digit after the decimal, and then I stick my 1 in there. 1.1 already has one digit after the decimal, so I don't have to add that in. I just put 1.1, and add another 1 after it. So what about back here between 0 and 0.01? Is that any trickier? It got trickier with the decimal when we started dividing, when we started adding in quarters and eighths and sixteenths. Well, we just added the quarters. Let's have a look at 1/8. It's 0.00. Can you guess it? 1. That's your 1/8 place. So if I want to add the 1/8 place to the next number, to 0.01, all I'm going to do is take my 0.01 and put a 1 on the end of it. So how do I do that with 0.1? Well, again, it's got to go in the third place. That's your 1/8 place. So we'll take our 0.1, add a 0 at the end of it to fill up that second place, and then put a 1 in the third place after the decimal. So 0.101. How about halfway between 0.11 and 1? Again, 0.11, and add 1 in our eighth place. So literally what this number is saying is 0 in the ones place, 1 in the halves place, 1 in the quarters place, and 1 in the eighths place. In other words, 1/2 plus 1/4 plus 1/8. Well, 1/4 is 2/8, and 1/2 is 4/8. So 4/8 plus 2/8 plus 1/8 is 7/8. And notice there are no more eighths left to add before we get to 1. How about between 1 and 1.01? Well, again, 1.01 in binary is actually 1 1/4. So this is going to be 1 1/8. Take our 1, put 2 zeros after it, and in that third digit after the decimal, put in a 1. That's our 1/8. We want to add 1/8 to 1.01, stick a 1 after it. We want to add 1/8 to 1.1, fill up the second place after the decimal with a 0, stick a 1 after it. We want to add 1/8 to 1.11, already 2 digits filled after the decimal, so put a 1 after it. A 1 0, remember, that's a 1 in the twos place, and a 0 in the ones place, so that's our number 2. What's halfway between 2 and 2 1/4? Well, 2 1/8. So we take our 2, put 2 zeros after the decimal to fill up the halves place and the quarters place, and then stick a 1 after it to add 1/8. Halfway between 10.01 and 10.1. Take our 10.01, put a 1 after it. That adds 1/8. Halfway between 10.1 and 10.11, take our 10.1, fill in a 0 in that second decimal, second place after. Why am I calling this a decimal point? It's a binary point. Seriously. Now, I didn't even catch myself doing that this whole time, and I should not have been doing that. I should go back and edit this thing and fix that. But you know what? I'm not going to. I'm going to leave my error in there. I hope anybody watching this doesn't stop just before I caught myself in that error. I'll tell you what. If you're watching this and you got to the point where I caught myself in that error, since I'm being nice enough to leave my error in there, please share this video. And I did not do this on purpose just to be able to say this, but please share this video, point out my error, or ask other people to watch it and just tell them I've got an error in there and tell them to watch it and see if they can catch it. And they'll find out I caught myself. All right. So, binary point, not decimal point. Yes, it's a point. It's not a decimal point when we're working in binary, because decimal point means that we're using decimal. Wow. I messed that up badly. Well, I think in a way my error sort of makes my point, because I'm very comfortable with binary. And don't get me wrong, I've been using decimal for a long time as well, so I'm pretty comfortable with it also. But I mean, a simple matter of fact, binary is simpler. And you get too comfortable with something, sometimes you sort of get lazy with it. It's sort of like when biologists talk about evolution as if biological evolution is the only kind, because they're so comfortable with biological evolution that sometimes they forget that there are other kinds. And there are some of them that they get so trapped inside of that little circle that they literally forget or don't even notice that there are other kinds. And they think when people talk about like the evolution of society or the evolution of a mathematical function or the evolution of anything else, if it's not biological, they think, well, that's a metaphor, that it's meant in terms of it's kind of like biological evolution, which is sometimes the case, usually not. And in that same sense, I used decimal point in mentally thinking in the sort of metaphorical sense. I wasn't really thinking, clearly thinking out what should be the term I'm using, because binary just really comes that simple to me. I mean, counting in binary, it's 1 1 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1 1 0 0 0. Every time you add 1 to a number that ends in a 1, that last digit has to become a 0, and 1 has to be carried over to the next place. So carrying isn't an exception in binary. It's more or less the rule. You're doing it all the time. But it's easy to do, because carrying 1 just means adding 1 to the next digit over. If that digit is a 0, well, then you just move it into that place. And if it's a 1, well, then you add it to the 1, you get a 0 in that position, you carry again. And so, for example, a number ending in 1111, if you add 1 to it, all of those 1s are going to turn to 0s, and you carry over into the place with the next higher order position. Really pretty simple. Although I know I'm not making it sound that way. At any rate, unfortunately, this video was over an hour long. I'm using an alpha version editor from Screencastify, and Well, while they're making good progress with it, it still doesn't handle those long videos very well. And one of my viewers, Ian Atkinson, I think was the name, um, pointed out to me that it was blanking the screen about halfway in, which would be somewhere around where we are now. So I've tried to resolve that, and I couldn't find any way I could re-edit it to make it work in the full length version. So I'm going to go ahead and end this now and make this part one, and then I'll work on editing a part two. I'll make an introduction to it and see whether or not I need a part three or want to add a part three. And if anybody likes this sort of thing and wants me to add more to it or continue along the same lines in future videos or expand into something related, please leave a comment. Let me know. Thanks for watching.